Okay, we're going to be talking about inscribing a rectangle underneath this parabola. So you know this is an upside down parabola, looks something like that. So what we're talking about with this area of this rectangle that has its corners that touch the top of the parabola like that. And the bottom of it is on the x-axis. Okay. So I know an area of a rectangle is like length times height, right? So I'll say width times height. Height, well, that is h. Doesn't that y value give me the height? Okay, so height is equal to the y value, and isn't that 12 minus x squared? It is. Okay, so 12 minus x squared is the height. Now let's talk about the width. So we know this is an x value, and this would be the same x value, right? It would just be in the opposite direction, negative x. So can't we say that the width is equal to 2x? We can. So my area is going to be 2x times the height, which is the 12 minus x squared. So that I'm going to multiply that out before taking the derivative, because that'll make it so much easier. And if I take the derivative, I get 24 minus 6x squared. Of course, we're setting this equal to 0. So 24 is 6x squared. 4 is equal to x squared. Oh, will you look at that? I get plus or minus 2. So that's the x value. So what they want, the dimensions. So if the x is 2 or negative 2, then the height would be 12 minus 4, so the height would be 8. So there would be your there would be the dimensions. All right, so then what happens if I make it a little more challenging and I say it's not under a parabola, but it's under this half circle? So this half circle thing is just going to make the algebra harder. Same idea, right? There's your this inscribed rectangle here. The height will be the y value, so that'll be this. And then the width is still going to be 2 x's. 2 of those same x values. So my area is going to be 2x times square root of 9 minus x squared. Okay, so you know we need to do product rule. So let's do it. First, d second, so 1/2, 9 minus x squared to the negative 1/2 times a negative 2x, so that's first d second, plus second d first, and that's times the 2. I always suggest we write terms with negative exponents in the denominator. And I'm going to look to see if there's anything canceled along the way. Oh, look at that. 2's cancel. Okay, so I get a prime is equal to, look at that, I get negative 2x times an x, so that's negative 2x squared. And then putting this term in the denominator, and then I carry this along, plus 2 root 9 minus x squared. Okay. So I'm setting this bad boy equal to 0. Okay, so I know I can just move this term over to the other side, right? So I get 2 root 9 minus x squared is equal to 2x squared root 9 minus x squared. So looking to see, oh, look at that. I can cancel the 2's. And then how about I multiply both sides by this radical? So if I multiply both sides by this radical, those go away. And so on the right-hand side, I'm just left with x squared. On the left-hand side, I get 9 minus x squared. Oh, so now I get 9 is equal to 2x squared. And then I can say 9 over 2 is x squared. So the x will equal plus or minus 3 over root 2. That's the x value. And then if you wanted to find the y value, you'd plug it back into the original function, 9 minus x squared. So you'd get root 9 minus, and if you square that, you'd get 9/4. So that's a y value, and that's the x values.